Hi everyone, welcome to our video on the effect of eggshell powder on soil properties using the Atterberg limits test and the standard proto compaction test. These are our group members: NOOR AINA NABIHAH, NOOR SALIHA, NOOR AZWA ARDINI and NISA NAJIHA. We are from class CEEC1104A. The objectives of the study are: first, to determine the liquid limit and plastic limit of the soil using the Atterberg limits test. Second, to determine the dry density and optimum moisture content of the soil using the standard proto compaction test. Lastly, to investigate the effect of adding 10% of eggshell powder on the plasticity and compaction characteristics of the soil by comparing untreated and treated soil samples. Next is background study of soil stabilization. Soil stabilization is a method used to improve the engineering properties of soil so that it becomes more suitable for construction purposes. It helps to increase soil strength, improve bearing capacity, reduce compressibility, and minimize volume changes caused by moisture variation. Nowadays, many researchers are using waste materials as alternative stabilizers because they are environmentally friendly. One of these materials is eggshell powder, which contains a high amount of calcium carbonate. This material has the potential to improve soil performance while also reducing environmental waste. Furthermore, background study for Atterberg limits test. The Atterberg limits test is a laboratory test used to determine the consistency and plasticity characteristics of fine-grained soil at different moisture contents. These are three important parameters in this test. The first is the liquid limit, which is the moisture content where soil changes from a plastic state to a liquid state. The second is the plastic limit, which is the moisture content where soil changes from a semi-solid state to a plastic state. The difference between the liquid limit and the plastic limit is called the plasticity index. A higher plasticity index indicates that the soil has a greater tendency to shrink and swell, while a lower plasticity index indicates better soil stability. Therefore, this test is very important for evaluating the effectiveness of soil stabilization. Next is background study for standard proto compaction test. The standard proto compaction test is carried out to determine the relationship between moisture content and dry density under a specified compaction effort. The results are presented in a graph of dry density versus moisture content. From this graph, two important values can be obtained, which are the optimum moisture content, or OMC, and the maximum dry density, or MDD. The optimum moisture content is the amount of water needed for the soil to achieve its highest dry density, while the maximum dry density represents the maximum level of compaction that can be achieved. Proper soil compaction is important because it increases soil strength and reduces settlement in construction projects. Next is the effect of eggshell powder on soil. Eggshell powder is a waste material mainly composed of calcium carbonate. When it is mixed with soil, it improves the bonding between soil particles and reduces the soil's plasticity. Previous studies have shown that adding eggshell powder can reduce the liquid limit and plasticity index, resulting in lower swelling potential and better soil stability. It can also influence the compaction characteristics by changing the maximum dry density and optimum moisture content.
The first test that we did is Atterberg limit test. It consists of two tests, which is liquid limit and plastic limit. The apparatus for cone penetration test or liquid limit test are shovel, rock picker, sieving pan, scraper and palette knife, cylinder cup, distilled water, moisture cans, weighing balance, glass plate and drying oven. The procedure for this experiment is: firstly, take sample for at least 400 grams. Then, pass the soil through 0.425 mm test sieve. At third and fourth steps, there is a treated only and untreated only procedure. For untreated only, at third step, transfer soil to glass plate and add distilled water and mix thoroughly with scraper and palette knife until become thick homogeneous paste. Fourth, Take 3 out of 4 of the sample and add distilled water so that the first cone form is approximately 15 millimeters. For treater-only procedure, the third step is transfer soil and eggshell powder to glass plate and add distilled water and mix thoroughly with scraper and palette knife until become thick homogeneous paste. Fourth, take 3 out of 4 of the sample and add distilled water so that the first cone form is approximately 15 millimeters. The fifth procedure is insert the soil sample into the cylindrical mold using a palette knife carefully so that no air is trapped. Sixth, remove excess soil on the surface of the cylindrical mold with a palette knife to make it smooth and flat. 7. Place the cylindrical mold containing the sample in the cone penetrometer. 8. Lower the cone until it touches the soil surface. 9. Set the dial gauge and record the initial reading. 10. The cone is released after 5 or 1 second. 11. The first cone penetration at least 15 mm. 12. Lift the cone and clean it thoroughly. After that, level and weigh the mass of 3 moisture cans. Then, take a small sample of soil and place it in a moisture can and weight it. Record the mass of the soil sample. Repeat steps 3 to 15 to obtain all 3 set data. After that, place the moisture can in the oven for 24 hours. And lastly, after 24 hours, weigh and record the mass of the moisture can again.
For the untreated soil finding, at a standard penetration of 20 mm, the liquid limit is recorded at 44%. To the finding after the soil is treated, the curve shift and at the same 20 mm penetration mark, the liquid limit is dropped to the 31%.
For the second attribute test, which is plastic limit, the apparatus are firstly, scraper and palette knife, empty container, distilled water, weighing balance, glass plate, and lastly, drying oven. The first procedure for plastic limit test is label and weight the mass of 3 empty containers. Second, take the remaining 1 out of 4 of the original soil sample from cone penetration liquid limit test. Mix the soil with a little distilled water until it becomes a uniform paste. That is only for the untreated only procedure at the second step. For the treated only procedure at the second step, take the remaining 1 out of 4 of the original soil sample mixed with eggshell powder from cone penetration liquid limit test. Mix the soil with a little distilled water until it becomes a uniform paste. Move on to the third step, which is roll the soil sample in the palm of your hand or a glass plate until it reaches a roll of uniform diameter of 3 mm. Fourth, break the sample roll into several pieces. Fifth, repeat steps 3 to 5 until each container is filled with at least 7 rolls of soil sample. The sixth step, weigh the filled container with soil sample immediately and record the mass of each container. 7. Place the container into the oven and leave for 24 hours. Lastly, after 24 hours, weigh and record the mass of the container again.
Next, let's examine the plasticity index and see how it changed the soil classification on the plasticity chart. For the untreated sample with a liquid limit of 44% and a plastic limit of 30.68%, the plasticity index is 13.32%. Plotting this on the chart, place the soil is the MI zone, which is still of intermediate plasticity. Next, look at the dramatic change in the treated sample, liquid limit of 31% and plastic limit of 28.89%. The plasticity index is 2.11%. On the chart, this plot much lower, shifting the classification to the ML zone, which is still of low plasticity.
Next, for standard Porto compaction test, the apparatus that we use is standard Porto mold, approximately 1000 ml volume, Porto rammer with 2.5 kg weight and dropping height of 300 mm, eggshell powder, 0.4 to 5 mm sieve, mixing equipment, steel straight edge, balance, measuring cylinders, sample extruder, and DL distilled water. Procedure for untreated and treated. First, take sample at least 3 kg. Second, pass the soil through 0.4 to 5 mm test sieve. For third step, there is untreated and treated procedure. For untreated, at third step is adequate water was added on soil sample to bring its water content to about 7% or less than the estimated optimum moisture content. For treated procedure, the third step is eggshell powder and adequate water was added on soil sample to bring its water content to about 7% or less than the estimated optimum moisture content. Then it was left for a while. 4. The mold and base plate were cleaned, they were fit and the mass were recorded. 5th, the collar was attached to the mold. 6th, the matured soil was remixed. About 2 to 3 kg of soil was taken. It was compact in the 1000 ml mold in 3 equal layers by using the hammer at 27 blows per layer. 7. The collar was removed. The excess soil was cut with the straight edge. 8. The mold was cleaned from outside and its weight was recorded. 9. The soil was taken out of the mold, kept a representative soil specimen from the top and bottom of the mold, and then weighed them for water content determination. 10. Soil specimen is left in the oven for 24 hours. 11. After 24 hours, the specimen is weighed. 12. Steps 3 to 11 will repeat about 4 times but with a gradual increasement of water content, each time by adding a sufficient amount of water to the soil. In a normal case of compaction, the mass of the soil weighed in step 9 became heavier for the first 3 compaction stages but will become lighter after the next 3 compaction due to the soil becoming saturated.
For the untreated soil finding, the maximum dry density MDD achieved is 1.74 gram per cm cubed at an optimum moisture content OMC of 19.61%. However, following the treated soil finding, the maximum dry density MDD slightly decreased to 1.67 gram per cm cubed, while the optimum moisture content increased to 22.5%.
Next is the discussion of Atterberg's limits. Based on the results obtained, the untreated soil recorded a liquid limit of 44%, a plastic limit of 30.68%, and a plasticity index of 13.32%. This indicates that the untreated soil is classified as silt of intermediate plasticity. After adding 10% of eggshell powder, the liquid limit decreased to 31%. The plastic limit became 28.89% and the plasticity index was reduced significantly to 2.11%. As a result, the treated soil was classified as silt of low plasticity. This improvement occurred because eggshell powder contains a high amount of calcium carbonate, which improves the bonding between soil particles and reduces the amount of water needed for the soil to reach the liquid state. Consequently, the treated soil became less susceptible to shrinkage and swelling, making it more stable for engineering applications. Discussion of standard Proctor compaction test. For the standard Proctor compaction test, the untreated soil achieved a maximum dry density of 1.74 grams per cubic centimeter at an optimum moisture content of 19.61%. Meanwhile, the treated soil achieved a maximum dry density of 1.67 grams per cubic centimeter with a higher optimum moisture content of 22.5%. This shows that the addition of eggshell powder increased the amount of water required to achieve optimum compaction while slightly reducing the maximum dry density. This happened because eggshell powder has a finer particle size and lower specific gravity than natural soil. In conclusion, the objectives of the study were successfully achieved. The Atterberg limits test showed that adding 10% of eggshell powder reduced the liquid limit from 44% to 31% and the plasticity index from 13.32% to 2.11%. This indicates that the treated soil became less plastic and more stable than the untreated soil. For the standard Proctor compaction test, the untreated soil recorded a maximum dry density of 1.74 grams per cubic centimeter at an optimum moisture content of 19.61%, while the treated soil recorded a maximum dry density of 1.67 grams per cubic centimeter at an optimum moisture content of 22.5%. Overall, the results show that eggshell powder has good potential as an environmentally friendly and sustainable soil stabilizer. Besides improving soil properties, it also helps recycle agricultural waste into useful construction materials.